Okay, section 2.2 is sets of sets. Sets of sets. Okay. It is possible that the elements of a set are themselves sets. Okay, consider the set set A, which is comprised of a set containing 1, 2, the null set, a set containing 1, 2, and 3, and a set containing just 1. The cardinality of set A is 4, because there are 4 elements. Those elements just happen to be sets themselves. The set that contains 1 is an element of A, but the value 1 is not an element of A. It's an element of another set. Okay. The empty set has cardinality 0. But the set containing the empty set has cardinality 1. Okay, example 1. Okay, consider set B to be equal to 2, the empty set, the set 1, 2, and 3, and the set containing 1. Okay. Okay, 2 is an element of B. Okay, just the element 2, okay, is an element of set B. So you could have a set containing individual elements or sets. Okay, but the set containing just 2 is not an element of B. Okay, the set containing just 1 is. Okay. However, the set containing just 2 can be said to be a subset okay, that is a subset of B. Okay, if we pull that 2 out and create a new set, okay, that subset is not an element of B, but it is a subset of B. Okay. Also, 1 is not an element of B, but the set containing 1, just 1, that is an element of B. Okay. Okay. Now here's where it gets a little confusing. Okay. We have this guy that is the element of 1. Okay. He is an element of B. So the set who's an element of B, the set 1 who's an element of B, is not a subset of B. Okay, let's just go back to our Venn diagram for a second. Okay, we're saying that we have, okay, we have in our set here, B, okay, we have 2, the null set, we have 1, 2, 3, and then we have that. Those are the elements of B, and some of them just happen to be sets. Okay. So 1 is an element of B. It's not a subset. It's an element of B. Okay. But if I drew a little circle around this guy, and I called this guy a subset, how would I designate that as the subset that contains just the set that contains just 1? We want the set that contains the set of just 1. It's going to look like this. The set that contains just the subset of 1, and this is a subset of B. Okay, we could call that C if we wanted to. We could say that is C. It's a little confusing. Okay, we can call that C. It's a little confusing in that what would be another subset of B? Another subset of B could be, we could call set D here the subset containing the empty set and the set containing only the element 1. Okay, and then that guy would contain 2 elements, one of which just happens to be, okay, and that is a subset. Another subset of B, which D is another subset of B. Okay, so we just happen to have C, which only contains that 1 element, and that 1 element is itself a set that contains just 1 element of the universal set. Okay, so yeah, these are also proper subsets, sure. Yeah. As long as they don't contain every element, then they're proper subsets too. Yeah. Okay, let's talk about a power set. Okay. A power set is the set of all subsets for a given set. Okay, the cardinality of the power set, so this is the number of elements in the power set, given the original set has n elements, is 2 to the n power. The power set A is denoted as P of A. Okay. Okay, the power set of A, 1, 2, and 3 are all of the subsets, okay, which could be itself. Okay, but what are all the subsets of 1, 2, and 3? Well, we could have nothing, that's the empty set. We could have the set containing just 1, the set containing just 2, the set containing just 3, the set containing 1 and 2, the set containing 2 and 3, the set containing 1 and 3, or the set containing 1, 2, and 3. And that is the power set. Okay. Notice that the cardinality okay, the cardinality, which we'll say is, we'll use absolute value bars to denote the cardinality. The cardinality of A is 3. But what's the cardinality of P of A? How many are there total here? Well, there are 2 to the 3rd. Okay, so the cardinality of P of A is 2 to the 3rd. It's 2 raised to the number of elements in the original set, which is 8. Okay. Let's do example 2 here. Okay, find the power set for B equals 5, 6, 7, and 8. Okay, so we've got 1, 2, 3, 4. So how many elements should I have in the power set? Yeah, 2 to the 4th, which is 16. I should end up with 2 to the 4th, which is 16. So let's see if what we get here. Okay, so let's look at our power set. I'm going to do this, okay, kind of in order. Okay, I'm going to say, well, what happens if I take none of the items? Or what happens when I take all of the items? Okay, so none of the items or all of the items. Okay. Then we want the set of each of the individual elements. So we can say that this is the set that just contains 5, the set that just contains 6, the set that just contains 7, and the set that just contains 8. Okay, now we want all the sets of 2 elements. So that's 5, 6, 5, 7, 5, 8, 6, 7, 6, 8, and 7, 8. Okay, comma. Okay, this is a continuation of a big set. Maybe I'll put, you know, big braces on this thing. You know, this is each a continuation of, you know, this is a set of sets. So just keep that in mind, that this is the outside bracket. Okay, that's the outside bracket of the set of sets. And I'm just listing them, but I'm doing them systematically. This is nothing or everything. This is the items just by themselves. These are the elements that the sets that only contain 2 elements. Now let's do the sets that contain 3 elements. So that would be 5, 6, 7, 5, 6, 8, 5, 7, 8. Okay, or 6, 7, 8. Okay, comma. And that's it. And I'm going to put my final ending brace there. Okay, final ending brace there. Okay, so what is the cardinality? Well, let's see. In this first row, there was 2, and then there was 4, and then there was 6, and then there was 4. And if we add all of that up, that does end up being 16, or 2 to the 4th power. Okay, 2 to the 4th power. So the cardinality is 16. Okay, and that is 2.2.